This is the load, and filters, capacitors are there, so that if there is any voltage fluctuation from the source side, this capacitor will take care. The ripples in the source voltage will be killed by the voltage filter. This capacitor act like voltage filter. So the operation is very simple. If this switch is on, so this short, this capacitor voltage is positive, negative, appear across the load. This load. Okay. This is off. This circuit is off. Okay. This attack KVL E not will appear. Resistive load. If resistive load, current and voltage are in the same phase. Now, in the second half cycle, when this is off and this is on, then the voltage polarity will change. This will be positive and this will be negative. So it is a alternating voltage. Okay. First mode, one is on. Resistive load is very easy. So Vs by 2, and when this is on, this is positive. This side is positive. This side is negative. It is Vs by 2. So you get a alternating voltage. Vs by 2, Vs by 2. If the it is a resistive load, the current waveform will be similar to the voltage waveform, except that the magnitude will change. This is for one switch, and this is for another. So yes, this is for inductive. That I will explain. So resistive load. Okay. Now inductive load. This is a purely say inductance. Okay. L. Now Q1 is conducting. Q1 is switch on. So current will flow through this, right? This direction. A2 current is flowing from A to O, right? Now when this switch is off, then what happened to the current? Current instantaneously change direction in inductor. So it will continue to flow. Imagine this is inductor, right? It will continue to flow in this direction. Okay. So it will flow in which direction? This is off. This direction is possible. No. It is a unidirectional device. Okay. So only this diode will be produced. Actually, what happened is that when the current start changing direction, L di by dt, voltage polarity will change, and that voltage forward bias is out, and the current will, the store energy in the inductor will be discharged through this circuit. Now, when this is conducting, please listen. When this is conducting, this cannot be turned on, because when in a practical case, when a diode is conducting, that is a voltage drop, positive, negative. Some voltage drop is there, so that voltage will reverse bias this transistor. Similarly, when this is conducting, that is a voltage drop, positive, negative. So this will reverse bias the diode. So both switch in parallel cannot be switched on. One is conducting, other is off condition. Similarly, here, if it is conducting, there is a voltage drop, positive, negative. So this is a reverse bias. When this is conducting, this is reverse bias. So when this inverse current is circulate freely through this diode, this is not on. Now, when the current through this diode reaches zero, it gets pulse previously used dark circuit. So this after this current is 0 here, this will start conducting and current direction will be like this. When Q2 is conducting, current direction is this direction. Similarly, when this is off, this current direction cannot change instantaneously. The current will flow through D1. Okay. Current through this is 0. This is off, and current will start flowing in this direction. The opposite direction. Just remember Q1, D1, D2, Q2. Okay. For a purely inductive load, the current will be like this. Okay. Q1 will conduct now, and Q1 will switch off. D2 start conducting. Current reach 0 here. Q2 start conducting. Q2 is off. D1 will conduct. Okay. So this slope is a constant. This slope is a constant. Therefore, voltage across the load is L di by dt. Slope is constant, L di by dt is constant. So this is a constant. D1 is conducting means current is negative. D1 is conducting means current is flowing in this direction. That is why it is negative. Q1 is conducting means current is positive. D2 is conducting means current is positive. Q2 is conducting means current is negative. I'm explaining again, when it is a resistive load, no problem, diodes are not required. Q1 is on, so the voltage not positive, negative will appear across the load. When Q1 is off and Q2 is on, current direction will change. Voltage polarity across the load will change. So we will get a alternating voltage across the load. Now, if it is purely RL load, if inductance is dominating, current direction cannot be changed instantaneously in the load. So diodes are required. So when Q1 is conducting in this direction, current will flow. When Q1 is off, but this is still in the off condition. Current direction will continue to conduct, and this will conduct to D2. When D2 is current is 0, it's automatically switch off, start conducting. Current will flow in the opposite direction. Similarly here also. Okay. So D1 is carrying the negative current, Q1 and D2 carrying the positive current. This slope is a constant, so L di by dt is a constant. This waveform will be a square wave, whereas current waveform will be like this. This inverter requires a 3-wire DC source, and when a transistor is off, its reverse voltage is Vs. Now, one more thing inverter in this inverter is that both transistors in the same leg should not be turned on at the same instant. If both are on, what will happen? It is short circuit the source. Positive, negative will be short circuited. Therefore, there must be a delay. When Q1 is conducting, Q2 should be turned on after a certain delay time. There may be a short circuit. And when one device is conducting, other parallel devices are connected in anti-parallel. Anti-parallel, not be turned on. So in this, the root mean square output voltage is Vs by 2. In Fourier series, the instantaneous output voltage can be expressed in Fourier series as naught by 2, that is the average voltage, plus because the voltage is Vs by 2, not Vs. And since this is a quarter wave symmetry along x-axis, even harmonics are not present. Only odd harmonics are present. Okay. So only Bn component will be there, and it will be 2 Bs by n pi. Okay. So root mean square voltage is Bs by 2. It is not, and the expression because quarter wave symmetry, average voltage is 0. Positive half and negative half are same magnitude, same duration, so average is 0. Even harmonics are not present, so the odd harmonics Bn component is 2 Bs by n pi. Therefore, the final expression for the instantaneous voltage is 135 infinity 2 Bs by n pi sine and omega t. Okay. This is the general expression for the instantaneous voltage of a single phase half phase inverter. So only fundamental, first harmonic, third, fifth, seventh, eighth are present. Seventh, ninth, 11th are present. So if you are asked to find the fundamental, just put n is equal to 1. If you are asked to find the third harmonics, n will be replaced by 3. Okay. For an inductive load, the load current cannot change immediately with the voltage. This I have already explained. The same thing what I have told you, that is what is written here. And the instantaneous current is given by, as I told you, even harmonics are not present. This is the expression for Vs and pi impedance into sine and omega t minus theta n. Theta n is the phase difference between the respective harmonic voltage and current, and harmonic voltage and current. So the fundamental power is P1 I naught on cos theta 1. Theta 1 will be tan inverse omega L by R. Theta 3 will be tan inverse 3 omega L by R, like that. Next is expression for source current. Like assuming that losses in matter, the average power absorbed by the load must be equal to the average power supplied by the DC source. So that will give you average source current is IS. Because the source voltage remain constant at any instant, VST is equal to small Vs actually. Instantaneous voltage always expressed small. Small VST is equal to Vs at any instant. So this becomes IS. Okay. So this is a full bridge. Full bridge. In case of half bridge, there are two switches and two feedback diodes, and a center F supply is required. 3-wire supply is required. There it is 2-wire supply. Capacitor should always be there in the source side for to keep the ripples in the input side. There is a fluctuation. The capacitor will take care. Okay. So here two switches conduct at the same time. Two switches. Now suppose Q1 and Q2 are on. Current will flow through Q1. This side is positive. A is positive. This positive voltage appear. EN. Okay. This VA not only VS but supply voltage VAB. VAB is equal to VS. Okay. Now, when these two are off, 3, 4 are on, then this Q3 source, Q3, V is positive, A is negative, positive, negative. So this negative voltage will appear. Okay. Now, if it is an inductive load, for resistive load, no problem. The voltage waveform is similar to the current waveform will be similar to the current waveform will be similar to the voltage after voltage waveform. However, magnitude will be lesser. Now Q1 and Q2 are on. So current inductive load is purely inductance. Current will flow through like this. Is this? Okay. Now when these two are off, current is not instantaneously to zero. It will continue to current in this direction. So it cannot flow through this forward bias. This unidirectional device. This is not yet on, so it will flow through D3 back to source and D4. D3 and D4. Okay. So D3 and D4 means current is in the positive direction. A to B. So when current is zero, current zero means these two becomes switched off, D3 and D4. So these two will turn on, 3 and Q4. So voltage polarity will change here. So negative V is positive, A is negative. And just see here, current direction is negative. Current direction is negative. Now, when these two are off, and continue to flow in this direction, D1 source D1 and D2. This D2 like this. Like that. Here also same case. If D3 is conducting, you cannot turn on Q3. Or Q3 is conducting, you cannot turn on D3. Similarly, all parallel combination. And one more thing, two switches in the same leg should not be turned on simultaneously, otherwise it will have a short circuit. Okay. It will have a short circuit. what is the difference between half bridge and full bridge? Here there are 4 switches. There is 2 switches, and output voltage magnitude is maximum here is Vs. There it is Vs by 2. So that is for low power application. This is a little bit higher power application. And anything else? And out with the operation of the switch. Inverter. Rest the table. Next one is switch Q1, Q2. This already I have explained. This is the RMS voltage, Vs, not Vs by 2. And same here expression for in the Fourier series. This average voltage will be 0. Fourier symmetry, even harmonics will be absent, only Bn will be present. Obviously, it is 4 Vs by n pi. In average, it is 2 Vs by n pi. So, final expression for the instantaneous voltage expression is sum of some n harmonics, fundamental and harmonics to infinity 4 Vs by n pi sine n omega t. This portion is not present, sine n omega t. So V naught 1 will be 4 Vs by pi sine omega t. V naught 3 will be 4 Vs by 3 pi sine 3 omega t. Right. So the instantaneous load current is 4 Vs by n pi square root of r square n omega l square sine n omega t minus theta n. Theta n is tan inverse n omega l by r. Any question? So you understand everything? Ready? Ready is sleeping today. Not present.
Hello.
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 Yes, sir.
Just 1 minute. I am listening. Hello. I'm fine. I'll call you within 10 minutes. So, so in what are you understand? Abhijit Das. All of you are sleeping.
Yes, sir. I can unmute that time.
Ready? Any question today? No question.
Sir, I have some questions regarding buck boost converter.
Tell me.
Sir, sir, when we calculate that output voltage ripple while calculating delta Q,
Buck boost converter, na? Okay, let's
Yes.
open the note. Which part you are telling? While calculating the voltage ripple, tell me not.
when we calculate output voltage ripple, sir, when we calculate delta Q, so we take the area below our x-axis. Sir, why don't we take the area above x-axis?
You can take, but which one is which will follow the easier path or the difficult path? It will be rectangle will be easier, na?
Sir, that delta Q, we are calculating delta Q from the graph of IC and time.
Yes.
So, sir,
That is the charge enclosed, na? That is charge enclosed.
yes, sir,
At
charge.
one cycle, then average charge enclosed will be 0. Average voltage across the capacitor is.
So that means, sir, we can either take the part below x-axis or above. So which one is easier? We are taking.
Yes.
And sir, in the last, there is some formula written with ESR, V naught ESR. So please explain that formula, sir.
Which one? That ESR means actually it is equivalent series resistance. Actually, we are taking ideal capacitor. Actually, capacitors are not ideal. The ESR connector, if the actual equivalent circuit of a capacitor is a capacitor plus a small resistance. Okay. In fact, inductor also having a resistance. If this type of question will be coming, then you take it. Otherwise, we'll take it ideal. If it is not mentioned, if ESR is not given, then we need not bother about it. But in fact, the equivalent circuit of capacitor is like this.
Okay, sir. Sir, one more doubt is there.
Actually ideal, and they are actually not ideal. Some leakage, some resistance will be there. Resistive effect will be there. And you have done machine lab. Resistance box you have used. Small cylindrical resistance box? No, not used. Any doubt? Ask me. Tell me.
Sir, one more thing is there. Sir, we usually we calculate delta I naught for switch closed and switch open both case. Delta IL, we calculate for open switch and closed switch both case. But sir, when we calculate this IL maximum and IL minimum, that is IL maximum.
Very good question. That you can take anyone.
Sir, in that formula we are taking.
But you take in both Imax and I minimum, any one you take. Come on. Yeah. Okay. Both any IL closed or IL open you can use.
Sir, but in the formula you used IL closed for.
I am telling. I have used you use IL open. Right? And use it, but you can also use, because you see IL close plus IL open is 0. Both should be same, na? What is the statement? Yeah. For steady state operation, the net change in inductor current must be 0 over a 1 period. Anyone? Good question. Can you use IL open or IL close? Huh?
Yes, sir.
Okay, you are able to download the node, I think, but you don't circulate to the world. It's not within you. Any question? Any more question? In what you studied today, whatever I teach you today, next class you ask me the doubt. So I am leaving